Take a look at our forces worksheet that we had for homework over the weekend here, starting with question number 8. The question says find the force of friction, but we had already solved for that. What we want to do is find the tension in the ropes that join all of these masses together. Well, we know that whenever we're solving one of these tension problems, we also call them, by the way, internal force problems, right? Because the tension is an internal force, a force that acts within the system as opposed to outside of the system or on the whole system itself. We want to find these forces of tension of these internal forces, Ft1 and Ft2. Then we've got to first find the acceleration. Now the good news is in this case, we don't need to analyze the system to get the acceleration because it's given to us as 2.0 meters per second squared. But in the event that it's not, then you need to find it. And we need to find the acceleration by analyzing the whole system. Bottom line is you need the acceleration however you come about that, whether it's given to you or whether you actually have to calculate it. All right, we have the acceleration. What do you do to find Ft1 now, the force of tension in that first rope on the left-hand side? We know this, right? We know this. What are we going to do here next? Analyze the system, then analyze what? The tension, which specifically we want to analyze one object, right? Which object do you want to analyze to find Ft1? Well, you've got a couple of choices. One is going to be easier than the other one. You want to analyze the object number 1 or object number 2? Which makes the most sense here? Come on. Number 1. Number 1 makes the most sense. The issue with analyzing number 2 is that there's two unknowns in that one. Ft1 and Ft2, we don't know what either one of those are. So we're going to have to do object number 1 first to get Ft1. Let's do that. Analyzing individual object number 1. We're going to pretend that it's straightened out here, like this, right? We take the object number 1 and pull it out like this. That means there's a force of gravity acting on that to the left. I'll call that F1, force of gravity acting on that one. And then we have a force of tension acting to the right, Ft1. That's it, right? That's all that's acting here. So what do we do next? Well, let's say F net is equal to the sum of the forces. F net is equal to F1 plus Ft1. F net is also equal to m times 8. What mass do I use? What mass do we use? 5, 3, 12, 20? 5. Yeah, I use the 5. Like it's easy to get mixed up with that, right? Because I said on the left-hand side, you always use the total mass. And the total mass of the system is 20, right? But what are we analyzing here? Individual objects, right? So we got to use the total mass, but of the individual object that we're analyzing, right? The total mass in that free body diagram, which is 5. Our acceleration is still 2.0. F1 is what? 5 times 9.81? Which is negative 49. Does that make sense? It's negative because it's acting to the left in my diagram, and it's 49 because it's 5 times 9.81. We add Ft1 to that. Add Ft1. 5 times 2 is 10. 49 goes over to the other side by adding, and I think we end up with 59 there. Ft is equal to 59 newtons. Is that right, Megan? Yes? There we go. Now, how many people did it that way? More or less that way, okay? If you tried to use the 3 kilogram object, like it's theoretically correct, but you end up with 2 unknowns. So what you'd end up having to do there is go back to the third object, solve for Ft2, and then use that to come back here. I think it's easiest just to start off with the 5 kilogram object. Now, having said that, we still need to find the tension in the other rope, Ft2. So for that, I don't know, you could analyze the 3 at this point because we have Ft1. Right, now that we know that this is 59 newtons, we could analyze Ft2 using the 3 kilogram object, but we're not going to do that. We're still going to use the object on the end. And as a general rule of thumb, that's what you want to do, is pick an object on the end. They tend to be easier to deal with. So let's do that. We've got our 12 kilogram object. We got our 12 kilogram object, object number 3. It's being pulled to the right by a force of gravity. We'll call it F12, or sorry, F3. We named them, F1, 2, and 3. And then we have a tension acting this way. That's it. We say m times a, 12 times acceleration of 2 equals ft2 plus 12 times 9.81. And 12 times 9.81 is 117.72. 24 on the left side. Take the 117 over by subtracting. Oops. Let's see here. 24 minus 117. Negative 94. Anybody get that? Yeah. Okay, are we good there? You're going to get a quiz tomorrow, and it's going to be on this stuff. But you only have to find one tension. It won't be both of them. But in the end, if you can find one, you can find them both anyways, right? It's just twice as much work, that's all. What was the other one you wanted to go over, number 12? 12, was it? 14? Oh, yeah. Yeah, I didn't ask number 12. It was 14, yeah. All right, so you want to find the tension in this. We had to find the acceleration. Now, if you have your work from before, when you were doing the other aspects of this worksheet, you would have already analyzed the system, and you would have already found that the acceleration in the system in question number 14 is 2.45 meters per second squared. If you don't remember how to get to that acceleration, then do the F parallel thing, right? If you have trouble with that, let me know. When you want to find an internal force, get the acceleration of the system, and then analyze an individual object. I'm going to choose to analyze the 5. I guess they're both 5. The second 5. This is going to be F2, we're going to say is 49.05 newtons. It's 5 times 9.81. And then we're going to find Ft this way. So we stretch it out. Ft acts between the 5s, 5 and the 5. How many people analyzed object number 2 there, doing this? How many people analyzed object number 1 doing this? Okay. I like number 2 better because I don't have to deal with that F parallel thing. If you analyze object number 1, then one of your forces becomes F parallel. But having said that, it's not really a big deal because when you were solving this question for the acceleration before, you got F parallel already, right? So you didn't have to do it again, right? Either way you look at it, you should get the same answer. Okay, we did it this morning both ways, and we got the same answer both ways. One was positive, one was negative, but the same magnitude both ways. Let's say F net is equal to the sum of the forces. That's going to be Ft plus F2. F net is m times a, so that's going to be, what, 5 times 2.45. Ft plus 49.05. 5 times 2.45 is, I don't know, it's like 12 or something like that. 12, take away 49. I think it works out to be 37, I want to say, 37? You got 37? Okay, you got 37, and you did it the other way, right? Using F parallel. Although you would have gotten, I'm going to get negative 37 newtons. You would have gotten positive 37 newtons, right? Okay, so that shows us that, look, 37 is the correct answer. If you got 37 using one object, and I get 37, who else did it my way? You did it? Okay. Did you get 37? Okay. You get 37 my way. You get 37 the other way. Like, you have to be right. Like, you have to be right. What did I say is a nice little check if you have time on your unit test? Do it both ways, right? Do it both ways if you can, if you have time. Although don't spend, half an hour doing it both ways and then run out of time on 3 questions. But if you have time at the end, go do it both ways. Yeah?
I got the same answer as you, but mine was positive.
Yeah, okay. Did you do it my way?
Yeah.
Okay. So if you got positive, then that means that you probably set, did you make these both negative? Negative 2.4 and negative 49?
Oh, no, in my head. It was negative, I
Just forgot to put the negative in there? Okay. I would accept positive or negative in this case just because of the way that you can do it, right? My way or the other way. Both answers would be acceptable. Yep. Well, if, no, the block, like this object number 2 block, you mean? It's going downwards, but the way that I drew my Foucault diagram, it's going to the right. Does that make sense? So what you could have done is kind of analyze it like this. And in that case, we would have said F2 would be, the force of gravity there would be a negative value. I don't know, it's just my thing that I like to make it horizontal, stretch to horizontal. Really whatever works for you. But your positive and negative is simply going to be based on the way you chose to do it, right? What your convention was when you do it. So sometimes you get a positive, sometimes you get a negative, depending upon how you did it. And as long as it's consistent, internally consistent, then that's okay. Is that okay?